Okay, so we are going to start by looking at 4.2 review. There were two questions on 4.2 that we needed to look at. One was number 19. So if you go back into your notebook for 4.2 and look for number 19, it was just a word problem, and it said the base and the height of triangle A are half the base and height of triangle B. How many times greater is the area of triangle B? Well, again, like I always say, they don't ask you to write these down, but you should definitely draw what they're telling you. So the base and height of triangle A, we'll call this triangle A, are half the base and the height of triangle B. So I'm going to draw something that looks like it might be about twice as high. So I know that if this is triangle B, my height is 2 times greater, and my base is 2 times greater than A, right? Because this is 1/2 of the base, and it's 1/2 of the height. So this is 2 times the base and 2 times the height. Now, how do you solve for area? Base times height. So if this is 2 times greater height, so height is 2 times greater, and base is 2 times greater, and area is solved by base times height, how many times greater is this triangle?
4, because it's 2 for each.
Right. It's 2 times greater for each dimension. So it's 2 times greater for height, and it's 2 times greater for base. So it's 2 times 2. That gives you 4 times greater. You have to remember that each one of the dimensions is multiplied by itself, base times height. So 4 times greater. All right, did we have questions on that one? Okay, and the other one that we are going to look at was number 20. So go ahead and draw this on your paper. We have this trapezoid here, and the fun thing about trapezoids is they're made up of a couple of already familiar shapes to us. How can we decompose this trapezoid to look maybe more familiar when discussing area, Naomi?
You can, like, from on the top, you can make, like, if you were to cut the triangle off and put it on the other side, it would become a rectangle.
Right, excellent.
And then 2 triangles.
Yeah, so we can end up making 2 identical triangles here, and this shape becomes a rectangle. Okay, so all we're really going to need to remember here is base times height, because we end up having a full square here if we move this piece to there. Okay, so we can think about them as triangles where we have to cut them in half, or we can recognize that this is really going to make a square in area is if I could cut it off and move it over there. So really we've got a small square and a rectangle is what we have here. So the other information we are given, what do these signs mean here?
Right angles.
Right angles. And what do we know about the measure of a right angle? 90 degrees. And they tell you this just in case you're thinking, well, is that an acute angle? Is it supposed to be 89 degrees? Is it 91 degrees? If it's a right angle, they will label that for you. It's just so you know what the angle of that is, the measure of that angle is. Okay, so this says, and go ahead and write this down, the total area of the polygon is 176 square feet. That is this triangle plus this rectangle plus that triangle. Okay, the total area is 176. We need to find the value of x. So let's get some labeling on here. If I label this, we know that this height is 8 feet, and we know that this base is 16 feet. Okay. If the height of this rectangle is 8 feet, what's the height of the triangle?
Wasn't the 16 on the bottom?
Nope. I mean, it's the same because it's a rectangle.
But wouldn't the entire It was separated in areas.
That's how it looks in big areas.
Oh.
Yep, you got X and X.
Like that one.
Yeah. Well, you will like it after this because you're going to learn how to approach it. Okay, so this is X and this is X. We are finding the length of this. Now, like Amelia had said, she said, well, didn't they tell you that this whole thing was 16? Well, if they had, it wouldn't be very much of a trick to find X, right? So we know that this base here is 16 and this base here is 16. What we need to know is what is the value of one of these X's? What is this base and what is that base? That's what we're trying to find out here. So it's kind of like a puzzle. We're going to be doing some multiplication and we're going to be doing some subtraction. So I know that the total area, this plus this plus this is 176. I need to find the value of X. All right. First of all, can we solve for the area of any of these shapes right now?
Yes. You can.
Which one or ones? The rectangle. 16 times 8. So when you've got 16 times 8, let me know what you've got. Kyla? 128 feet squared. And that represents, and I'm just going to kind of shade this in just a little there, that represents this grade area here. Go back to the problem. The total area of the polygon is 176. If this is 128, what do we do with the information now? Naomi? 176, which is the total of all three pieces, minus the 128, which is the piece here, is 48. Okay. So what does this 48 represent?
The area of the triangle.
It's the area of these two triangles combined. In other words, it's the area of one
So wouldn't it be
square.
the X
Okay.
divided by 2 would be the area of the triangle? But no, because it's 8.
Well, you can think about it two ways. So Gavin says, well, if I divide it by 2, it's the area of one triangle. So let's do that. Divided by 2 is 24. So this area is 24, and this area is 24. Okay, so let's solve it that way. So what do you know about this triangle so far, Gavin?
Well, it's half a square, so you can still divide 24 by 8 to get the base.
Yep. So you're going to take the 24, because you already cut it in half. So you're already looking at this triangle's dimensions. So 24 divided by the 8 that you know, which is the height. 24 divided by height, which is 24 divided by 8, gives you X, and that X is equivalent to 3.
I put 3 in and it didn't.
But that's a 3 here and a 3 here, because you cut it in half. You were solving for one triangle. This triangle has that same base, right? So it's like you have to take this base and this base if you solve it like that, because you cut it in half. Because really, when you combine them together, what have you got? You've got a square, right? So this is the base of one triangle, and this is the base of the other triangle. So you have to add them together. Now, you only have to do that if you cut this 48 in half. You cut it in half because you said, well, I'm dealing with triangles, so I cut them in half. Perfect. But you have to remember that you now have to solve for each triangle. If you solved it thinking that, hey, these two triangles make a square, what could we have done with the 48? If you're thinking these two triangles together make a square, and you know the square is 48,
It's 23.
you know this is 8 because it tells you 8 right up here, and so this X is worth 6.
But since it's a square, it has to have 6 sides.
Because it's a square, because you didn't cut it in half, this 6 is already combining the two bases for you. But when you cut it in half, you were only solving for one base then.
They're asking for what X is, though.
Yeah.
And if one X is 3.
X is going to be 6 because this is the same base as this. And when you add them together, that's the base. So this base, X's are going to be the same value in this problem. So if this x is worth 3, then this x is worth 3.
Yeah, I get that, but
So the base is 6. Because this 3 plus this 3 is 6.
right. Okay.
So I think maybe I know what you're saying, Amelia. So are you saying that even if I transfer this over here, it's not on the base, that base is 3?
Well, no, because it says find the value of x, so I assumed
Mhm.
it was x equals 3.
Oh, okay. So one of the x's is 3,
Yeah.
but this is really x plus x. So yeah, you solved for the value of x, but then you had to combine like terms. So there were 2 x's together. So you could think about it as a square and not cut this in half. Or you could think about it as a triangle and cut it in half and then add them together.
Yeah.
Okay. Are we feeling okay with that?
Yeah.
All right. So I'm going to stop this recording and